See dear students, now we are going to discuss how to find domains of some functions given, which are very important model for 2 marks. Every year in Maths 1A, you will definitely get one sum based on domains. How to find domains for 2 marks, 100%. Even for competitive exams also, these are very important. Now see first bit, f of x equal to 1 by x square minus 1 into x plus 3. Now this function is in the form of 1 by g of x. Means a function which is in denominator. Okay, so whenever a function is in denominator, this denominator must not be equal to 0. Why? Because what do you mean by domain? Domain means the values of x for which the function is defined. Defined means gives a particular answer. Suppose if g of x is equal to 0, you will have 1 by 0. 1 by 0 means it is not defined, isn't it? So therefore, this denominator must not be 0. Therefore, here this x square minus 1 into x plus 3 must not be equal to 0. So you should check in what cases this denominator may be equal to 0. First of all, see here, x square minus 1 we can write as x plus 1 into x minus 1 because it is in the form of a square minus b square into x plus 3 must not be equal to 0. So x plus 1 will not be equal to 0 if x is not equal to minus 1. Here this one, x minus 1 will not be 0 if x is not equal to 1 because if x is 1, it becomes 0. Here also, x must not be equal to minus 3 because if x plus 3 is 0, x will be minus 3. So, clearly, domain will be now, how to write domain? All real numbers except these 3 values, that is minus 1, 1 and 3. So, this is the domain of the given function f of x equal to 1 by x square minus 1 into x plus 3. Next sum. We have to find domain of f of x equal to 1 by root of 1 minus x square. Now here also the main part of the function is in denominator. So initially the denominator must not be equal to 0. And also here if you observe 1 minus x square is under root. So any number under root must be, any number under root must be positive or equal to 0. But when it is in denominator, suppose if you are having 1 by root x, then x must be only positive. X must be only positive. It cannot be equal to 0. It can neither be less than 0. So according to this concept, you should write like this. For domain of f of x, which is given here, 1 minus x square must be strictly positive. Okay, this is first condition. So up to here, you will get 1 mark out of 2 marks. Now how to write the values of x? See always, it's a quadratic. X square means it's a quadratic. So make x square coefficient always positive while deciding the answer. So you can write it as x square minus 1. You have written reverse now, becomes less than 0. Factorizing x minus 1 into x plus 1 less than 0. Okay, therefore the roots will be here 1 and minus 1. Now I will tell you a concept here. When you are having x minus alpha into x minus beta less than 0, so that alpha is smaller root than beta, then this is true only when x lies between alpha and beta. This is very important concept to be remembered. You are having a quadratic form x minus alpha into x minus beta which is less than 0, so that alpha is a smaller root. Then this is true only when x lies between alpha and beta. If x takes values between alpha and beta, then only this product will be less than 0. So here the roots are, smaller one is minus 1 which is alpha, bigger one is 1 which is beta. So according to this concept, here x belongs to minus 1 to 1. This is considered to be domain. Therefore domain here is x belongs to minus 1 to 1. Okay, next question everyone. Here we are going to find the domain of the function defined as f of x equal to square root of x square minus 3x plus 2. So we are going to find the values of x for which this function is defined. Now here it is clearly under root. So whenever a function is under root, it must be positive or equal to 0. It cannot be equal to 0. When the function inside the root is negative, it is not real. Okay, so therefore for domain, here for this particular function which is given, the function part x square minus 3x plus 2 must be positive or equal to 0. Now let us factorize it. x square minus 2x minus 1x plus 2 greater than or equal to 0. Taking x common in this 2, x minus 2, taking minus 1 common, x minus 2 greater than or equal to 0. Now take x minus 2 common, you will have x minus 1 greater than or equal to 0. Now let us see an important concept. When you are having x minus alpha into x minus beta greater than or equal to 0, so that alpha is the smaller root. Alpha is the smaller root among alpha and beta. Then here x must be less than or equal to alpha, that is smaller root, or x must be greater than or equal to greater root, which is beta. In such case only this is possible. So again repeat, x minus alpha and x minus beta will be positive or equal to 0, so that alpha is less than beta. Then x must be less than alpha or x must be greater than or equal to beta. In such cases only this is true. Okay, so according to this, here smaller root is 1, which is alpha, bigger root is 2, which is beta. Therefore we can write is x less than or equal to 1 or x greater than or equal to 2. Less than or equal to 1 means 1, 0, minus 1 up to minus infinity. So x belongs to minus infinity to 1. Here closed, here open, because equal is there now. So you should write closed. Or means union 2 to greater than 2 means 2, 3, 4 up to infinity. So this is domain of the given function. So this is the main synopsis which you have to remember. This is the main part which you have to remember, which is applied here to find the domain. Now let us find domain of f of x equal to log of x square minus 4x plus 3. Now it is a logarithmic function. For a logarithmic function, that is, if you are having log x, x must be always positive. For such numbers only logarithm values are different. Okay. So therefore, according to that concept, here for domain of this particular logarithmic function, the function part which is x square minus 4x plus 3 must be positive, must be clearly positive. Okay. Now let factorize this. X square, 1 3s are 3, 1 plus 3 is 4. So minus 1x minus 3x plus 3 is positive. Take x common, x minus 1. Take minus 3 common, x minus 1 greater than 0. Now take x minus 1 common, you will have x minus 3 positive. Now let us see the synopsis which is to be applied here. What is that? If you are having x minus alpha into x minus beta positive, so that alpha is smaller root among alpha and beta, then this is true only when x is less than alpha or x is greater than beta. Very important concept to remember. That means x must be minus infinity to alpha union beta to infinity. In these values only this particular product will be positive. Therefore, according to that, here 1 is alpha because that is the smaller root. 3 is beta, that is bigger root, isn't it? So therefore, domain directly you can write like this according to this concept which you have to remember, that is x belongs to minus infinity to smaller one is 1 union 3 to infinity. So let us find domain of f of x equal to 1 by log 2 minus x. So here logarithmic function is under denominator. First of all, here since it is logarithmic function, this 2 minus x must be always positive. So taking x that side, 2 greater than x or x less than 2. That is initial point to be remembered. And also mainly here, since it is in denominator, log 2 minus x must not be equal to 0. In denominator, any function must not be equal to 0. Okay. Now from logarithms we know log x is equal to 1 or log x is equal to 0 only if x is equal to 1. So applying this concept here, 2 minus x must not be equal to 1 because in denominator log 2 minus x must not be equal to 0. Log x is 0 when x equal to 1. But here since it should not be equal to 0, 2 minus x must not be equal to 1 according to this concept. So minus x must not be equal to 1 minus 2. Okay, take to that side. So minus x must not be equal to minus 1. Removing minus, x must not be equal to 1. Here x less than 2 means x belongs to minus infinity to 2, and in between these you will have 1 no, but you should not take 1. Between minus 1 infinity to 2, you will have 1, isn't it? Minus infinity, so coming up to 0, next 1, next 2, no. In that 0 to 2, you have 1, 1 should be removed. So how to find domain? Therefore, domain is minus infinity to minus this 1. Set notation, you should write it this. See everyone, next one. Find domain of f of x equal to square root of 2 plus x minus square root of 2 minus x by x. So here x is in denominator, initially should not be equal to 0. First point is that. Next, this is 2 plus x is under root. So 2 plus x may be positive or equal to 0. That is, x must be positive or equal to 0 means 2 going that side becomes minus 2, no? So x must be greater than or equal to minus 2. That is first part. Okay. Next, here 2 minus x is there. 2 minus x also, which is under root, must be positive or equal to 0. That is, minus x must be positive or equal to minus 2. Remove minus, the symbol changes. X less than or equal to 2. Okay. So here, combining these all, x is greater than minus 2 but less than 2. Means x belongs to minus 2 to 2. This is actual answer according to this. Minus 2 more than minus 2, less than 2. But in between, there will be 0, no? Minus 2, minus 1, 0, 1, 2, no? So 0 must not be there. So removing 0. So this is way of writing domain for this particular function. See next question. F of x equal to square root of mod x minus x. What do you mean by mod x? Mod x means it is x if x is positive, minus x if x is negative, 0 if x is equal to 0. This is definition of modulus. ఇంకా డీప్గా మీకు అర్థం కావాలంటే mod of minus 2 means you write 2 because it is minus of minus 2 or mod of 2 is 2. Now here, first of all, this is under root, no? So mod x minus x must be positive or equal to 0 always. Now suppose if you take x 2. Suppose if you take x2 here. If you take x2 here, then mod x minus x will be what? Mod 2 minus 2. Mod 2 is 2 only, no? 2 minus 2, 0. Okay, it may be 0. Next, suppose if you take x minus 2. Mod of minus 2 minus of minus 2. Isn't it? Now, mod of minus 2 is 2 only. Minus of minus plus 2. 2 plus 2 is 4. Natural integers, you can take fraction also. Mod of minus 1 by 2 means you are taking x equal to minus 1 by 2 here. So minus of minus 1 by 2, which is clearly 1 by 2 plus 1 by 2, 1. So therefore, if you observe here, nowhere you are getting negative answer. You are getting 0 or positive answers only. You are not getting negative. Though you are taking negative, you are getting finally positive answer only here. Here also, we are taking positive means 0 you are getting. When you are taking positive value, you are getting 0. When you are getting negative value, you are getting then also positive values. So here, clearly, for any real number, for all x belongs to R, mod x minus x is either positive, see these two cases, or equal to 0 as in this case. So you can simply write like this. For all x belongs to R, mod x minus x is positive or equal to 0. Therefore, domain is x takes all real numbers, that is R. R is the domain. Okay? Note down. See next question. We are going to find domain of f of x equal to x minus mod x. Clearly, since it is under root, x minus mod x must be positive or equal to 0. Now let us check with some examples. Suppose if you take a positive value x2, then what is this 2 minus mod 2? Mod 2 is 2 only, no? So 2 minus 2 is becoming 0. Okay, if you take x sum 2.5, then 2.5 minus mod of 2.5, that is 2.5 only, which is clearly 0. Okay, so whenever you are taking positive values, you are getting only one answer, that is 0. Now let us take negative. Suppose if you take x minus 1, what happens here? Minus 1, minus of mod minus 1. Isn't it? So minus 1, minus of, this is anyhow minus 1 only, no? Mod of minus 1 is 1. So minus 1. It means you are getting a negative answer, which is minus 2. You are getting negative answer. So it clearly indicates that we should not take negative numbers. Suppose if you take x minus 1.5, this will be minus 1.5 minus mod of minus 1.5. That is minus 1.5 minus of 1.5 under modulus is 1.5 only, which is minus 3, again negative. So you are getting negative numbers means you are getting negative answer. If you take x0 also, no problem. X minus mod x will be equal to 0 only. So clearly all answers are 0. So range is 0 here. Range means the answers which you are getting. So domain here what? You should take only all positive real numbers. So you should write like this. For all x belongs to R plus union 0. Or you can also write it like this. X belongs to 0 to infinity. 0 to infinity. So for all x belongs to 0 to infinity, this x minus mod x is positive or equal to 0. Therefore, domain for this is x belongs to 0 to infinity. 0 to infinity. Like this you can write for 2 marks. Okay? Note down. See next question. F of x equal to square root of step x minus x means step x is nothing but the other form of greatest integer function. So what is the meaning of greatest integer function? So step x, how do you define it? Step x. Suppose x is a number between two integers, n or n plus 1, it will be equal also. Then greatest integer function means it is defined as n. That means suppose, example I will tell you, step of 2.3 or integral part of 2.3 means it is clearly 2. Because 2.3 is a number which lies between 2 and 3, isn't it? So the integer part of this is 2. Suppose if you take minus 2.3, then minus 2.3 lies between what integers? Minus 3 and minus 2. Therefore, step of minus 2.3 will be clearly this one, minus 3. So remember this. If you understand this concept clearly, then you can understand this also. Here, step x minus x must be positive or equal to 0. Now let us see for what cases it may be positive or equal to 0. Now let us take for example x some 3.1. Okay. Now if you take step x here, step of 3.1 minus 3.1, it will be 3 minus 3.1, which is negative here because it is minus 0.1. So it indicates that you should not take 3.1 like this. Okay. Next, if you take step of minus 3.1, then this will be minus 4 now. Then step x minus x will be, this is clearly minus 4 and minus of minus 3.1, which is minus 0.9. Again negative you are getting here. Again you are getting negative answer. So though you are getting positive or negative, you are getting negative only. Now let us take pure integers. Pure integers. That is, if you take x3, then step x will be equal to 3 only. Then step x minus x means 3 minus 3, which is clearly 0. So for all integers, step x minus x will be equal to 0. 0 is a defined answer. Only one answer you are getting. So therefore, step x minus x will be only 0 if x is clearly an integer. X is clearly an integer. Okay. See here, suppose x is minus 2. Then step x will be minus 2 only. Here minus of minus 2. Step x minus x means minus 2 minus of minus 2. Minus 2 plus 2, 0. Like that. If you take x2, then 2 minus 2 direct 0. Therefore, at integers only it is becoming 0. It is not becoming greater than 0 also. Therefore, clearly this we take as domain. So domain of f of x given here is x belongs to z. So z is the domain of this particular function.